All right, thanks everyone for having me here. This presentation is sort of called How Architects Can Use Computer Programming for Design and Documentation or Automate the Boring Stuff in Architecture. And what I'd like to talk about today is just like how I've sort of learned how to use computer programming and programming related tools in my architectural career and how that's actually sort of changed my career a little bit, and how I can encourage you to, if you don't want to actually learn this stuff yourself, how you might encourage your younger staff, your students, or use this with a consultant to be able to take advantage of the power of our computers to do some extra stuff with our designs. So my name is Dan Howard. I'm a registered architect. I graduated from Penn State in 2006. I've been at Ballinger in Philadelphia since that time. Started off as a designer, grew into a project architect, and then sort of made a bit of a left turn to become what we call a computational design specialist. And I'm also the leader of the Philadelphia Dynamo user group, which you'll learn a little bit about Dynamo tonight if you don't already know. So I don't usually like long intros on the speaker in these types of presentations, but I wanted to give a little bit of my background just to help explain how I came to this knowledge and why I think any of you here can benefit from this. So when I was in school, I actually learned a program called Form Z in my second year, and I hated it. I did not want to learn how to do 3D modeling. I did not find it conducive to my design process. I didn't like it at all. So after this required, half semester of that, I barely touched it at all for the next 4 years. And in fact, in my thesis, it was all hand-drawn. But I did then sort of scan my stuff, bring it in and layer it in the computer with some photographs and things and textures to make some more interesting drawings. So I wasn't against using the computer in general. I just didn't like the 3D modeling part because I didn't find it very intuitive and applicable to my design process. When I started at Ballinger, I started off working in some AutoCAD projects, but then actually started working on one of our first Revit projects in the office, which was this building here. It was never built, but it was kind of a crazy crazy geometry for this building. And thank God we actually had Revit at that time because it made the documentation so much easier. Being able to have our sections actually model this geometry and get accurate plans without having to try to do sort of the projection from a 2D drawing or anything like that. So I started to recognize that Revit could be a really good tool. And in fact, in college, I declined to take the Revit course because I thought the 3D modeling was too much. I didn't want to do this. Fast forward a couple of years, I was working on this project. Again, didn't end up getting built, but it was the Public Safety Services campus for the city of Philadelphia. Half this building was going to be the Department of Health, half was going to be the police headquarters. And it was about a 500,000 square foot project, and each half of the building had a different numbering scheme for their rooms. And if you imagine trying to number all of those rooms after you've gone through schematic design, that could be a real pain. We'd had a BIM consultant that said, hey, why don't you use Dynamo? This can help you renumber things really fast. And I thought that was a great idea. And I quickly realized there's something in here that's a little bit harder. We need to have like a letter prefix, and I couldn't quite figure out how to make that work with Dynamo, with just sort of out-of-the-box Dynamo. So I started to learn Python, which is a programming language, like a regular programming language, to help supplement my Dynamo use. Fast forward a couple years after that, and I'm working on this project, which actually finally did get built, which is the Department of Taxation for the state of New Jersey up the river in Trenton. So we ended up using the Dynamo skills and the Python skills that I developed on those previous projects to realize this curtain wall facade and sort of really dynamically generate this thing that would have been really hard to do with our traditional tools. I'm going to go into more detail about how this project actually developed at the end of the presentation, but that was sort of my journey. And after that project, I realized I enjoyed the programming part of this more than I enjoyed RFIs and submittals. And so I decided to stop being a project architect and try to start doing sort of this computer programming, data, and, intelligent design stuff a little bit more, a little bit more consistently. So I want to go through the learning objectives. I'm not sure if we actually getting this, if the credits have been approved through the AIA for this yet, but define automation and computer programming, how they're being used in architectural practice, list the similarities and differences between text-based computer programming and visual programming, figure out what types of tasks are easy to automate, what makes tasks harder. That one I might actually rely on you guys to ask some questions about at the end. And use a case study to demonstrate how visual programming and scripting can make design problems easier to analyze, visualize, and solve. So what I actually want you guys to take away from this is you don't need to have a computer science degree to do programming. You don't even need to learn programming to make use of it. You can have your younger staff, you can have your BIM consultants do this stuff. And what I really want to encourage you to do is just know a little bit about the language of this and how the process works so that you can speak intelligently to them about like how your design processes work and how programming and scripting may be able to help you out. And basically all automatable processes can be broken down into very simple steps. It's really amazing that the computer is super fast, but it's really dumb. And so if you want to make it do what you want, you have to give it the simplest, most unambiguous instructions ever. And all automation relies on sort of the underlying data definitions and things like that. So if you ask your BIM consultant or your intern to do this, they're going to ask you a lot of questions back about what do you really mean when you say this stuff. So this first part of the presentation is going to be a little bit technical and dense, but I'm going to try to get through it quickly because I just want to give you guys, again, just a basic sort of understanding of what this stuff means. Before I move into that, I'm just actually kind of curious. How many people in here use Revit? Okay, about half. And rest in like AutoCAD, or are you in like ArchiCAD or AutoCAD? Okay. And does anybody here use Dynamo or has ever done any sort of like computer programming before? Couple. Okay, great. So this will be new to pretty much all of you. Oh, I forgot this one part of it. For whatever reason, that one text was an animation on here. Okay, so what is programming and what is automation? So programming is just the act of entering instructions for a computer to perform. So you're going to tell the computer in specific language, do this thing, then do that thing. Or if this condition is true, then perform this action, otherwise do something else. Do this certain thing a certain number of times. Keep doing this until some other condition is true. Automation is just the use of technology to perform tasks where human input is minimized. So some examples of how I've used some automation to improve our practice is creating sets of sheets from an Excel sheet list instead of having to manually create them one by one. If we find out that our intern has not done all uppercase on our text notes within the thing, we can very quickly put together a script that just makes everything uppercase instead of having to retype everything. Reformatting images for specific purposes. If you're in Revit and you have like colored plans that are based on data, you can sort of automate the creation of these color filters and things like that, or automate the bringing in data from AutoCAD drawings directly into Revit. Or as you'll see in the final example, applying patterns to a facade. So computer programming and algorithms are basically the similar terms. So an algorithm is just a set of instructions to be followed to perform a specific task. So some examples from your everyday life would be following a recipe. If you follow the recipe, you're going to get the dish out at the end. Driving directions from Google Maps, that's an algorithm. Turn left, turn right, go 800 feet, then turn this way. The long division and finding the greatest common divisor that you learned in middle school math. Those are algorithms. They're just steps that get you to a result. So this is an example of an algorithm that gets you to a paper crane. If you look on the left, it's text-based. It says, start with the square piece of paper, fold it in half, open it, then do this. Or you could do it graphically. So this diagram just explains exactly how you'd get to the same result going through the same steps, but it just does it in a different way. So all computer programming and all scripting is basically the same idea as that. It's just using language that the computer can understand. There's a bunch of different computer programming languages. So the ones that I've used are Python, JavaScript, C#, SQL. They all have different purposes. There's some graphic programming languages, which are a little bit more visual and easier for architects to understand. So some examples of those are Grasshopper for Rhino and Dynamo for Revit. And they all have, there's some languages that are general purpose and some are more specific to certain applications or for working with different programs. So my primary tools that I use almost exclusively are Python, which is a general purpose programming language, Dynamo, which is a visual scripting language for Revit, and pyRevit, which is a plugin for Revit that allows me to write Python code and use it with my Revit models. So just some really quick fundamental elements of programming: data types and data structures, logic and conditional statements, looping over instructions, functions, and then extending your programs with the work of other people using libraries and modules. So when you start talking to somebody about how you can use a script, they're going to really start to grill you on how do you want this data to be defined? What are the data types for this? Things like strings, which is really just text. Things like exact types of numbers. You know, an integer, which is a whole number, is different than a floating point number, which is sort of like the scientific notation you learned in, in physics or chemistry class. And even decimal numbers are represented slightly differently inside the computer. And depending on which one of these you use, you might get a very slightly different answer for certain problems. Boolean values, which is based on Boolean logic, is just true and false. Okay, that is the sort of fundamental building block underneath of all sort of computer programming. Is just true and false, which is sort of the equivalent to a 1 or a 0 if you ever hear about binary code, or yes and no answers. And there's also a value called null or none. And if you don't account for how you don't have a data value for certain things, it can cause problems. There's also a million different complex types of data that are specific to the language and the purpose that you're doing. There's data structures like lists and dictionaries. So a list is just an arrangement of pieces of data, and the order kind of matters. But otherwise, other than the order, you can't find the piece of information that you're looking for. There's dictionaries, which are a key value pair, which basically says, okay, for this entry, the first name is Dan, the last name is Howard, and is he registered? That's true. Or if you're talking about a car, the make is a Subaru, the model is Legacy, the year is 2010, and the mileage is, some number. And then these data structures can be combined together to form like more complex data structures. The things that you can do with different types of data are dependent on what type of data it is. So for instance, you can only do math. This sounds like a really dumb thing. You can only do math with numbers. You can't do math with text, right? So if your data is formatted as a piece of text, you can't add up the areas of something. You can only add that up with numbers. So for instance, obviously 1 plus 2 equals 3, but the text of 1 plus 2, depending on the language, is going to come out to 12 because it's just squishing those things together. Or if you try to sort some objects into order, and it says 1, 2, 3, but spelled out, you're actually not going to get 1, 2, 3. You're going to get 1, 3, 2 because that's the alphabetical order for those words. There's also logical operations. 5 is greater than 2. That's true. Is the word Zeke in the list of Alice, Bob, and Carl? No, it's not. So that value is false. So using all of these things together, you can build up some logic for how you're going to process through your different things. This is a diagram that just sort of explains, like, here's how flow works in a computer program. This is actually not even, on the left side, it's not even a program. It's just say, like, should I bring an umbrella today? Okay, I'm going to start. Is it raining? Yes. Okay, do I have an umbrella? No. Okay, maybe I should wait a while before I can go outside. This is the exact same thing, but in Python code. Is it raining? True. Do I have an umbrella? False. And then if I go through the code here, if it's raining and if I have an umbrella, I can say go outside. And if I don't, I say wait a minute. And the result is wait a while. There's also loops where you can do things a certain number of times. So if we write a program that says go through this list 5 times, which is sort of what that range 5 says, and add a number to it each time, it'll give you this output, and it'll just add a number to it each time, depending on how you want it to go. You can also loop through your data structures. So if I have my club members, Alice, Bob, Carl, Dinesh, Amelia, and if I write some code that says, go through all of those and just tell me based on their age, are they a senior member, a junior member, or just a regular member? You'll get out at the end, okay, Alice is a member, Bob is a member, Carl's junior, Dinesh is a senior member, and Amelia, we don't have the data for her. So she's unknown because that's a null, we didn't put that data in. So we need to account for those ones where we don't actually have the data. Functions are like mini programs within your program. So basically, if I write a function that says, say hello, and what's the name? Did you bring snacks? And if you didn't bring snacks, or if you did, what were they? And I can say hello name. And if you brought the snacks, then say thanks for bringing whatever the snacks are. So if Keith didn't bring snacks and Bill didn't bring snacks, but Lee did, so it'll say hello Keith, hello Bill, hello Lee, thanks for bringing chips, because those are the values that I put into there. Often other people have solved similar problems to you, so a lot of your code can actually just reference other people's code, and you don't have to do everything from scratch. So this is a short example of some code that I wrote just to process through some Excel data that we had to say, like, based on our entire staff list and their age, what generation were they? Because we're doing some sort of demographic studies for an annual meeting. OK, so that's the text part. That's over. So now this is graphical programming, which is what, if you get into it with Revit or Rhino, this is more like what you're going to be looking at. So graphical programming uses the same underlying building blocks. It just does it visually instead of with a bunch of dense text. So in graphical programming, you have nodes, which are these boxes. Each box does a specific purpose. And then you have wires that connect them. The data flows from the left side to the right side. So if I have an input thing here where I can put integers for 7 and 5, and then the data flows through the wires to this subtraction node, and then I can get the result out. So 7 minus 5 equals 2. So the inputs come in from the left side, the outputs go out on the right side. And you can also connect the outputs from one node to multiple other nodes, so you can reuse this data many times. So I can do the same, I can do addition, subtraction, and multiplication on all those things without having to rewrite the same numbers over and over again. OK, so this is an example of not a very complex script, but what it starts to look like when you start to put multiple of these steps together. And I'm actually going to do a little, I'll explain sort of what's going on with this, and then I'll do a quick little live demo of how this actually kind of works. So on the left side in these green boxes, we have a little slider where you control what number you want to put in. The top one is the number of points in the x direction. The middle one is number of points in the y direction. And then the bottom one is the distance between the points. And then we put them through, some other things to say, like, generate a list of numbers between the start and stop, and then create a grid of points at that location. So switch over real quick here to my Revit. So you can see here, if I turn my background off, I have a grid of points here. And if I change my number in the x, you can see that that grid of points grows in one direction or grows in the other direction. Or if I change my slider down here, the distance between those things changes. So what we can actually then do, if we connect the output of that to a node over here that says, take a simple chair family from Revit and place it in the model according to those coordinates, I can actually place this array of chairs in here. And when I actually change the parameters of those, the actual numbers change. The actual arrangement of the chairs change in Revit. So you're actually controlling your real model, your real design with this programming. We can also then start to add in a little bit more complex stuff. Like if I start to do some add in some random numbers to say offset these points in a random direction, and I change how far they can be offset, I can start to sort of simulate as if the party's over and all the chairs are moved out of place. And in fact, I can even do more where if I want to say, who's ever going to keep these chairs straight, let's turn them around so they actually look like they've been used and turned around. So again, this is like a very trivial example, but this is an idea of how you can build up from basic building blocks to build these more complex things. And by the way, please stop me at any point if you have a question. I'm happy to answer questions anytime. OK. All right. So this is just explaining some of those nodes in there. We don't need to go through this. So here's some examples of where I've used this technology in our practice. So we had a big academic building where we wanted a sort of slatted ceiling to go through the entire corridor at an angle. And you can see it's kind of a complex shape. So trying to model exactly the start and end points of every one of those slats was going to, if someone had to do that manually, take forever. And if we ever wanted to change it, forget about it. It's going to take an extra day or two to do it. So if we put it in a program, we can control all those things. So the same way we control the number of chairs in that other example, we can change the spacing for the slats or the angle for them or what size they are or anything like that. This is an example where we had an existing building and we were trying to fit a bunch of ceilings underneath existing structural beams. And we'd go through and for each room have to, depending on the ductwork and the beams that were in there, we'd have to move the ceilings by different heights. And we were just having a hard time understanding, like, what are the actual heights of all these rooms. it's hard to get a big picture when all you're just reading is little numbers. So we used Dynamo to actually color code all of the ceilings so we could see where are the low zones and the high zones based on our actual conditions. Ballinger is an architecture and engineering office, and our electrical engineers had a problem where Revit out of the box doesn't allow you to do clearances around cable trays. Just doesn't do that for whatever reason. Does it for ductwork and everything else, doesn't do it for cable trays, but they wanted to run clash detection on them and make sure that they were coordinated. So I put together a script and actually made this little user interface box here that allows them to specify what's your top, left, right side clearances, and then it actually brings that geometry into Dynamo, and in the end builds a box around all that stuff. And if they need to change it, it just updates like that as soon as they rerun the thing. They don't have to try to remodel all that stuff over again. One of the tools that I use actually a lot of the time is called pyRevit, where I can actually write text code and have it be integrated with my Revit model. So this is an example of an actual script that I wrote that does this. We have to do these room data sheets or room definition sheets, and each one has 4 elevations, a plan in RCP, and a 3D axonometric view on each sheet. And but we've got 50 of these things, and try to make a sheet, each one of those, make the views, place them all on the thing consistently. That's a lot of work for an intern or something to do. So I wrote a script where you could just select the room, hit the button, and it would generate the sheet for you.
How long did it take you to write that script?
A little too long, but probably all in all, I would say maybe day and a half, 2 days maybe. I was already familiar with sort of like the programming part that's behind this that runs inside of Revit, so I knew where to look for it. If you're just learning it, it would take you a month to do this because you wouldn't know where to look for stuff. But as you get better at it, you get a lot faster at it. Yeah.
Could you then take that particular script for that particular project and bring it into another project and have it do the same thing?
Absolutely. This would work on any Revit project at all. Okay. So it's not specific to this building.
What kind of file is that?
So to run this, you have to have, so you see up here, there's this pyRevit tab on my ribbon. So you have to have pyRevit, which is a free add-in for Revit. And then it's actually a .py file, which is a Python code file. And there's a specific folder structure that you have to have and load it into your pyRevit tab. But once you do that, you can actually put your own buttons up on your ribbon, and you can make all of your own tools just built into Revit as if What
version of Revit are you running?
This is 2023, but this is available for everything since like 2018 or 2019. Okay. So every version that Autodesk currently supports for licensing, you can run pyRevit on.
Okay, thank you.
Yep. This is an example of another script where we have to do, for these big institutional buildings, a graphic program that lays out, with colored blocks, every single piece of program. But we always start off from an Excel spreadsheet of all these things. So I wrote a script that takes in all this stuff, compares it to, based on the department or the function or whatever the definition is, and says, here's the colors, blue, yellow, green, whatever it is for each department, and then arrays it out on a 2D drawing in Revit to give you all that, thing. So you don't have to sit there and spend hours just drawing rectangles. You can generate this, and then if you want to rearrange it, you can of course rearrange it however you want. And if you need to do this, 30 times throughout your, schematic design process, or for 30 different departments, you're not spending weeks doing this. You're spending like an hour. So this is, I want to actually talk more in depth about the project I flashed up at the beginning. So this is the Department of Taxation for the state of New Jersey. And this is the project where I think I had the most impact with my coding work, which is on generating this facade. So early in the design process, we settled on this sort of rounded corner box. We wanted it to be an all-glass building, and we knew that we couldn't do a ton of different moves with like mullion caps or different materials in the facade. We needed to be just glass to keep it sort of a bit economical, even being a curtain wall building. But we wanted to find some way to make it interesting just by using the glass in an interesting way. So there's the sort of geometry of the building and the massing. We came up with a couple of different ideas. Some of them were using randomly dividing the panels, using a frit on the glass. inserting metal panels either in big vertical like a barcode, or sort of randomly putting metal panels around. In the end, we decided on the randomly divided all glass panels because it kept everything, you know, in one system, and it was the most economical use of the material. So how do we make a random facade? We did it the first way at first, having the intern do it. We just said, make this look random, and they kind of changed, you know, they'd pick a panel and move it and change the color on it, and that was good enough for schematic design. But we knew that wouldn't work overall when we were trying to get into what's the exact ratio of the glass types and things like that. So we could also do things like develop, you know, a sort of mega tile of different glass panels and then repeat it around and flip it and turn it around. But in the end, you'd probably end up seeing some, you know, artifacts. You'd see the same little mini pattern repeated. Or if we wanted to actually change the ratio or something, it would be hard to do. So we could also create an algorithm, a series of steps to arrive at a random pattern and manually apply it. So go through 1,000 different curtain wall panels and apply the pattern manually. Or we could automate it with Dynamo. So I obviously chose Dynamo. One of the things that I want to sort of point out is that sometimes when we say random in computers, the result doesn't look like true randomness. So if you look at you know, this thing where we sort of just tried to color code based on a random selection, you find areas where there's, you know, four blue panels in a row, or, you know, a solid stripe of red or something like that. So we had to come up with a process for how do you actually still do it randomly, but have the distribution be a little bit more even and more sort of look a little bit more random. So we settled on this idea of doing permutations of the different combinations of panel types, and then shuffling those all up and then applying those around the facade. And so we ended up with sort of, you know, a patterning like this, where there might be one or two panels that are the same, you know, type next to each other, but it's a lot more sort of evenly distributed around. You can see, like, within that section there, no two colors that are the same touch. So we ended up with a pattern for how we divided it, and then we needed to color it. We decided that we were going to try to use different reflectances of glass to get this patterning. We actually did a lot of study on some Viricon glass products to try to figure out what are the right ones to actually get an effect that we wanted. And we used the scripts that I developed to sort of say, like, what's the ratio of the different types? Can we actually study this, and does this make the facade, you know, more interesting by saying, is it more or less of one type? And you can imagine trying to do this by hand would just be a nightmare. So the scheme that we ended up doing was we chose the middle reflectance value. This arrow is in the wrong spot. It should be pointed to that one. That was 50%. That was our base case of it. And then for the higher reflectance and lower reflectance, those were 25% of the total panels. And the rule was that the high and low reflectance panels can never directly touch another piece of glass that's the same type. So if you look through here, you'll see that with either the light blue or the dark blue, they never, on an edge, directly touch another panel of the same type. We wanted that to be a rule just to make sure that we didn't ever, with these, you know, more highlight pieces of glass, ever get things that, you know, start to become into big bands or blocks or anything like that. That took a lot of coding in Python, building the Python into the Dynamo script that applies this to the facade, but we were able to make those rules work. And by checking each of the adjacent panels, we could come up with different versions of this. So in the end, we generated about 20 different potential patterns. We got it in front of one of our design principals, and he looked at each one and said, yeah, I think I like this one. So we picked that one and actually made it into the building and got it built. So the project was finished in the spring of 21, and it's over in Trenton on John Fitch Way. I'd encourage everyone to go see it because there's nothing else that looks like this in all of Trenton. So lastly, I just want to point out a couple of resources. If you are interested in learning any of this, if you want to encourage any of your, oh yeah, sorry, go ahead.
Off topic,
Yeah.
but how did you, all glass building like that, energy usage,
Yes.
how was that maintained to meet COMCHECK or whatever it may be?
So the primary thing is that we did really efficient mechanical systems. So we've got our engineers in-house and made sure that our mechanical systems are really efficient. We also chose all of these types of glass have, you know, really good heat gain coefficients and reflectance values and things like that. So even though they're different visual reflectances, they all perform really well.
Was it triple glazed or?
No, just double glazed with a 5/16 light on the outside to try to keep it a little flatter.
Right.
And I think it was argon filled, but I can't remember. But yeah, I mean, like we were up against them. We were actually evaluating with the state a lot of like, do we make this into a strip window building? And we really fought against that because we thought it's just not going to have the same presence as a new modern office, state office building if it's strip windows with metal panels. We did incorporate frit into a lot of this. It helped a little bit with some of that shading and stuff. And there's a lot more stuff that happens with the frit pattern that's not part of this talk. But
This was completed in 21?
yeah.
Is it occupied?
Mm-hmm. Yep. Yeah, the first couple months they were only at like 10% occupancy because it was the middle of pandemic. But yeah, it's more or less fully, as much as any office is fully occupied anymore, it's fully occupied. Yeah.
Since it's completed, it probably is a brief question, but have you considered the new film that I've been reading about that will go on windows that will generate electricity? And this for things exactly like that, instead of, it doesn't reduce light coming in or the advantage of the sun, but it takes out of the sun the things that are needed for solar energy. And that's something you've been looking at or not?
We didn't consider that. Adding a lot of other expenses in terms of like films and things was not something that we could really do too much. And the state, once we sort of with our mechanical systems hit where we needed to be, they weren't really interested in trying to go that extra mile on additional films and performance and things.
Okay. Is it a LEED building?
It is a LEED building. Yeah, it's LEED gold.
I'm sorry?
LEED gold.
Gold.
Yeah. Yeah.
I missed in the very beginning of your presentation what your background is, what your education is. How did you go from coding into architecture?
I went from architecture into coding. So actually, I graduated with a B.Arch from Penn State, and I spent the first 10-ish years of my career. I was really good with Revit and modeling. After I got out of college, I kind of embraced that. But I just had a problem that was like, coding can maybe help solve this, and I got really interested. And my wife can tell you that I probably ignored her a little bit for a month or two while I was really learning it. But then I was just always looking for more opportunities to use it. And eventually I sort of said, well, I can't answer RFIs and submittals and do coding at the same time. And I bet we could use someone that does more coding here because we have 250 people in this office. So this is what I do, more or less full time now, amongst a bunch of other things, data operations and things like that. But yeah, I went from architecture to coding. So you don't have to have a computer science degree or anything like that to learn this. You can pick it up. There's a ton of like online resources and things to learn this stuff. Yeah.
Do you have a GitHub?
I do have a GitHub. Yeah.
Okay.
Yeah. A lot of my repos are private, but some of them are public. I've never tried to push out anything in GitHub, but there's stuff that I'm like, I'll put it out there and see if it makes it.
With all of the Python code and everything, did you use like Stack Overflow for a lot of it? Were you able to, I guess what I'm asking is, was there a lot of community that you were able to pull from?
Yeah, there's actually, most of this work I did in Dynamo, in the visual programming language. And the Dynamo forums are actually a wonderful place. If you post a question on there, as long as you've done your homework, which is the same for any forum. If you ask the question that anyone has been asked a million times, they're going to get mad at you. But if you've run it through a Google search once or twice, they're happy to answer your question and work on your problem with you. And there's, we haven't had an event in a little while, but there's communities like the Philadelphia Dynamo user group. We put our events up on YouTube, so there's a lot of resources online just to learn this stuff. Yeah.
Were you primarily self-taught, reference guides, forums, that type of situation?
Mm-hmm.
Did you have any outside help or?
In terms of coding,
Yeah.
I am 100%, well, I can't say that. I'm like 97% self-taught. I took a C# class a couple months ago, like intro to C#. But yeah, I've learned this all on my own just because I was interested. Yeah. Yeah.
Does the pyRevit connect directly to Dynamo, or is it you
They're totally separate. So you can, they interface with the underlying code differently. So you can do the same things with each of them. It's just that sometimes it's a little easier or harder in one versus the other. Like Dynamo's way easier to pick up early on when you're just trying to solve like simple problems. But when you get into some like really complex logic, I find that Dynamo just gets a little too cumbersome, and I find actually programming in Python makes it just easier to organize all of my code, keep it straight, revise it, that kind of stuff. Whereas the spaghetti mess of all the wires in a really complex Dynamo graph just gets to be too much after a while. Yeah.
I know a bit of Grasshopper, but I don't know if there's like any like simple coding like between them where you can upload something from Grasshopper into Dynamo or if it goes the other way.
No, so there might be like a plugin or two that's a few years old that actually translates between them, but you don't need it anymore because now they have Rhino inside Revit, so you can actually run a Rhino engine within your Revit model, and then you can run a Grasshopper script through Rhino on your Revit model. So if you do Grasshopper, you can already do this stuff. You don't have to learn Dynamo. Sorry, 1 second. Yeah.
Your approach using Dynamo versus Python. So in Python, you make your smaller modules and you kind of group it in Dynamo. You use that to like pull it all together.
So Dynamo makes the process of interacting with the model, like finding the objects and things like that, a lot easier and faster. And especially like early on when you're just trying to figure out like, how might I make this process work? I'm just trying to hack my way through it. Dynamo is really good because you can see your results right away and you can sort of play around with it. But later on, if it's a really complex problem, especially if it's a thing where you've got to, you've got a list of 1,000 objects and you've got to process through the entire list. And sometimes you do operation X and sometimes you do operation Y, and in the rare case you do operation Z, but only if the previous X was something else. That type of logic is just more difficult. You can do it in Dynamo. It's just a little bit more difficult because of the way that, putting the wires and things together. Whereas in Python, that's just sort of the way that you learn to do text programming, is that you build up that sort of literacy in doing those problems. Yeah, so you got a question?
Yeah, what I was going to ask was, since you're dealing with a lot of visual stuff, when you first were like introducing yourself into all of this programming stuff, did you find that it was easier to do like pseudo-code, like that text box thing that you showed us where like, hey, is it raining? Yes, no.
Yeah, so I recognize the value of pseudo-code and I get really bored with it because I really quickly want to get into actually writing Python. So I'll start to process it out in terms of like, okay, I think I need to do this, then do that. But very quickly I'm like, I don't know how this data structure is going to work with this operation, so let me just start coding it and I'll see what happens. It's probably not the most efficient process, but that's kind of the way I do it, yeah. Yeah.
Maybe it's like a request to oversimplify, but like when you compare like the time spent defining all these variables and all these things, and overall compared to the process of project, I guess it will be a big chunk into that first schematic design, and obviously there will be a gain in the construction document production, but to get a raw idea, how much it adds to that first schematic design in terms of like, we're talking like we should consider 50% more of the time, like.
It's hard to answer because it really depends on what the problem is. So, and it also depends on your skill level, because obviously the stuff that I did to make this, I could do it probably 2 or 3 times as fast now as I could do it back then. Just because I understand things a little bit better, I'm a little faster in kind of recognizing the concepts. It's something where depending on what the task is, if it's something like, for instance, generating a bunch of sheets where you can do it in about 5 or 10 nodes in Dynamo, or like I said, changing all of your text or something like that, or looking up one thing from an Excel file and then inserting that data in. You can, even with very little experience, you can put that together in like an hour or two, and if you know what you're doing, it's a 2-minute exercise. But when you have something where it's like, I've got 1,000 rooms that I've got to process this way, or I've got 1,000 text notes, and to sit here and manually change them, or to try to check on one screen my Excel file and then type my thing in over here, that's what, you start to see the gains very quickly on spending that hour or two setting up that initial script. But it does take time to get fluent and familiar enough in it that you can be efficient in making something that works for a more complex task. Yeah.
So what I would ask is, you went from being an architect to being a programmer, essentially. Would you say that that's almost what it needs to take for something like this to work in any architecture firm, where like you have almost like a dedicated programmer that understands what's happening in the firm, like in the architecture firm, to be able to write these things? Because I'm kind of like on my IT for trading. I've dabbled in programming, but I couldn't tell you the first thing about how I would be able to write Python code for ArchiCAD.
Yeah. So I think that for a larger office, eventually they'll all have somebody that's, if not a computer programmer by training, but someone that's very enthusiastic about it, that has picked it up. And you'll find a lot of like the bigger end firms have departments of this now for computational design and stuff. Depending on what problems you need to solve, you don't need a programmer, but you do need somebody that's interested and enthusiastic about it, because it's not something that you can pick up and run with in an hour. It does take time to learn it, and especially when you get into more complex problems, and learning a language like Python or something, to actually have, it's funny because like the books that are the beginner books for Python teach you a bunch of really cool stuff, and they don't tell you anything at all about how you make that work in Revit, or how do you, use a filtered element collector to query all of the different, object types or whatever. So it gets complex when you get into those bigger problems, but you can use it without even having to do these really big problems. And once you get that familiarity and you start to get that leg up, take that first step up there, the next problems become a little bit easier. And so, even if you don't have someone on staff that is going to dive into this and make that their full-time job, or even their 25% of their job or whatever, if you understand how these processes work, you can get your BIM consultant to do it, or you can just hire someone to be like, I have an idea for how I need to do this. I want someone to write a Dynamo script or a pyRevit script or whatever to solve this for me.
But the fact of it is, in order to do the actual coding, you know what your end result, what you want for an end result.
Yes.
Because you're an architect. So in the same vein, a structural engineer would know what he wants as the end result and perform his computer to do the work to get to that end result. If you were not an architect, you couldn't do it.
Yeah, you do need someone to translate. You may not need an architect or someone with an explicit architectural background to do the actual coding, but you do need someone that can speak both languages. Maybe not fluently, but that's why I sort of want to encourage a bunch of you to sort of just learn a little bit about this, because when you start to understand a little bit, okay, I'm breaking this process down into these minuscule steps of just grab everything, pull this piece of data out of it. Now that I have this piece of data, then if it does this, then do that thing. That's the fundamental building blocks of all of it. And so if you can understand that, you can communicate with a programmer that says I want you to take all of my rooms and get the department out of it. Okay, now that you have the department, if it is the Department of Biology, then do whatever else. So you need to you need to have a little bit of translation between the two of them.
Getting data out of something that's already there is fine, but when you're putting something into it, that's where you need the architect right there doing that.
Yeah.
As an instructor.
Yeah, and like, if you give your, it's the same thing, honestly, as if you give your intern out of school a problem that they don't understand, you know, and you don't spell it out for them, they're gonna get it wrong. So yeah, you do need to spend some time on, unless it's like a really trivial problem, you do need to spend some time just defining what are the parameters of the problem. Yeah, I'm gonna keep moving around, but I'll answer every question you have. I've got a hall pass tonight. I can be here forever. So yeah.
So what I'm hearing, if you use Revit, there's a list of things that Revit can't do. I would rather. So it sounds like with Dynamo, you're saying you really need to move to Python to maximize Dynamo. Like, you know, I mean, Dynamo, you know, set up sheets, push out stuff, label rooms.
Yeah.
But it sounds like you quickly found out there's limitations to Dynamo. I'm sorry.
There's not.
Or did you want it to do like amazing stuff like this that pushed you into Python?
I found that for us, there's this idea in computing that if you have a language that can do the basic stuff, you can make that language do everything. So like there's simulations where they've taken like a little checkerboard that has dots move around, and they've simulated entire massive computers on that. It takes ages to run because it's like not an efficient process. But you can get any language to do just about anything if you're willing to spend the time on it. What I found was that for a certain type of problem, I just enjoyed doing Python more, and I would write my Dynamo script up to a certain point and then realize I just would rather do this in Python. And so I would do that, and then as soon as I got the hard part out of it, I'd go right back into Dynamo and keep doing that. That doesn't say I couldn't have done that exact same thing. It just would have required a lot more spaghetti, and it's a little harder on those really complex things. It's harder to just keep track of stuff visually. I mean, it's the same thing when you are looking at a massive site plan. It's very hard to understand all of it, but when you can look at all the little details individually, it becomes a lot easier. I find that looking at the details becomes a little easier on those complex problems when I'm actually dealing with it in code. Yeah. Too slow.
So what I was going to ask is, I know when you're getting into this, it can be a little scary. Like, oh shit, what if I mess something up?
Yeah.
So I guess, did you take on the practice of making testing backups of all of this stuff, and then testing your code on one of those things? So if you were working on this building and all of a sudden this cement or something, it didn't affect the project.
Yes, save as is your best friend. I would, every time I would start a problem like this, I would, unless it was again something like super easy that I knew I could get done, I would make a separate environment. I would copy my model over, or just deal with a simpler problem, because you end up ultimately needing to deal with simple problems to tackle the complex problems. So, why go into the deep end if you're just trying to understand the little kernel of the problem? But yeah, I would do like that example of the cable trays. Like, that's just a little study model that I put together to just be like, can I make this work? Can I, if I put, a T junction or an over and under, I don't even know what you call those things, but have that kind of bridge over something else, is this thing gonna work? I know that we have these conditions, let me see if I can account for them before I give them something and have them come back, a month later when I've forgotten half of what I did, and say like, oh, it doesn't cover this problem. Let me see if I can, do it in a test bed first and put it through what I think is like the breadth of the design space that might be the issue.
And real quick before going to Mike, sorry Mike. documentation. I know
Hmm.
that's like everyone's beginning of existence
Yeah.
because, especially going into Python, you know, you start working on something, you go to something else for a day, and you come back to
Yeah.
that same code, and you're like, what was I thinking, or
Yeah.
where would this go? Like, I guess, how are you proceeding to make sure that the next person who takes over
Mhm.
for you can like continue that?
Yeah. I try. I'm not the best at leaving comments in my code. You do see that, like in my scripts, I do these like colored boxes that group things together, so at least I can understand like here's a sub problem, and here's how I've put it together, and so you can kind of, without having to look at each individual node, you can understand the overall flow of it. But yeah, that's a real challenge, and like especially on a more complex thing, like you can kind of see, here's the graph down here for all the stuff that made this cable tray thing work. It's a challenge, and it takes some time to go back and do that. But when you come back to it a month or 6 months or whatever later, it's like it's really vital. It's the same idea as like using def points in AutoCAD. Like if you use def points to put notes about why you actually did stuff, or like you got to align this thing there because we've got this, you know, overhang up above. You know, making smart use of those things just saves you time later because you know why you did something that may be a little bit, you know, not intuitive.
You know, you brought up a good point in the sense that where do you, when you're testing these things now, and something goes south, how do you know how far back to go to figure out where to help? I mean,
So,
where do you draw the line and say, when should I test this?
so I started off as a test. I don't work on the actual files until I'm pretty sure that it's gonna work. And even then, I make a copy of the files because just in case I screw up everything and it deletes everything, I don't want to delete everyone else's work or all of my other work. So I start off just copying it to somewhere else, making sure that it works, and when I'm confident that it actually works, the nice thing about like programs is that even though they're doing massively complex things, they can do it like super fast. So like, you know, one of my examples that I didn't show on the screen but mentioned was like we needed to reformat a bunch of images to go on a database website for our interiors library, and they had all these images of different sizes, and I wrote a script to do that, and I just copied all of their images to a new folder and ran through it, and like I'd keep running it and be like, oh, it didn't cover this case, let me run it over again. And in the end, it could process 1,300 images in about a second, and you know, get everything done. But because it goes so fast, you don't really feel bad about like copying your stuff over, running it, see if it works, try it over again, delete the messed up one. You know, there's also a thing that in the actual scripting, and especially if you're using like Python code, it's a little harder in Dynamo, but there's a thing called version control, which is rather than, you can use it on your actual data files, but it's primarily for when you're writing code. You get a bit of code to work, and then you do what's called a commit, and it puts this bit of code into a repository, and you put a comment on there and says, I got this thing to work. And then maybe you have an idea later on and you sort of branch out and do something else, and the version control software, it's called Git, is the biggest one. But that lets you sort of, it keeps a full record of everything you've ever changed. Every time you commit it, it keeps a record of that. And so if you ever find like, oh, I screwed something up 3 saves ago, you can go back to that version of it and sort of retrace your steps. So I wish we did use version control software on so many more things, even like Word documents and, you know, stuff like that.
Is a compiler required for this program? These programs?
Python, and I guess Dynamo, when you kind of consider the way it does stuff, they're all interpreted rather than compiled.
Okay.
If you get into a program like C#, that's actually a
Right.
compiled program,
Right.
or C or C++, or some of those ones. So what actually happens when you run a Python script is it opens the Python engine, feeds your code through it, and then translates that into a lower level code, C, or eventually it goes down to like machine code.
Okay.
So it all does assembly and machine code and everything, and it translates it down. So you don't have to compile these things ahead of time.
It does it automatically.
It does it automatically, and the trade-off is that like Python is orders of magnitude slower to run than like C or something. So you might not, like you wouldn't code all of Revit or AutoCAD or ArchiCAD or anything like that. You would never code a massive program like that in Python because it's just too slow. You do it in a faster programming language. But for these things where especially we're just trying to test out ideas, it doesn't matter if it's slow because it's still faster than I am in running, you know, a million instructions.
What are you running it on?
Just on my regular computer.
Regular desktop?
Yeah, this laptop or my
Laptop?
yeah, this laptop or my desktop at work. Yeah, just a regular
Nothing
computer.
special.
No, if it were like a really complicated problem, you could maybe benefit from a faster computer. But like for most problems that we're going to come up with, like maybe it sits there on a really hard problem with like a model where it's doing a bunch of operations in the actual model. The Revit part's the slow part. The program's not the slow part. So like interacting with and moving all the stuff around in the Revit model is actually what's causing it to slow down. And that might, like I've had some of these things where it runs for half an hour or so. Or like when I said that I had, we generated 20 different options for that facade pattern, I actually gave my, you know, junior architect, I said, here's the script, run it and tell me, you know, not every version of this, not every like seed value for the randomization works. Give me 20 different versions that work. And because each time it takes 5 or 10 minutes to run, and I just didn't feel like sitting there to do that. So I had him do it and then tell me which versions actually worked. And then we could proceed on with those versions. But yeah, it takes a little time to run.
So just to confirm, this Grasshopper-esque program, that's Dynamo?
That's Dynamo, yeah.
And then pyRevit is the script-based version?
pyRevit is the script, yeah. So yeah, so this is Dynamo, and it's like if you know Grasshopper, you've got the same basic idea. What each one of these actual nodes is called and the way it looks is a little bit different, but the concept is the same. So like, yeah. So pyRevit is the Python one. Dynamo works with a bunch of different Autodesk products, but if you're using Rhino, you can use Grasshopper. There is some coding languages for like ArchiCAD, and you can do, there's like an API, which is like how you get one program to talk to another program. That exists for like AutoCAD and for a bunch of other stuff. So there's ways to interact with almost every piece of design software. It's just that like some of them make it easier. So like Revit makes it really easy with Dynamo. And then when they made, and like pyRevit, it was like somebody's pet project. That's not a paid thing. He just decided to do it because he wanted to do it. And released it to the public, and you know now it's used by a ton of different people. But he used the API and then made a Python, or used someone else's Python interpreter, and built a whole ecosystem for it. So
my second question is there any caveat to using an API, where let's say like you mentioned, if you're going from Rhino and you're putting some Grasshopper scripts in there, and then you're bringing it into Revit, is there any restrictions that you run into?
No, I mean, so like there might be restrictions on, I'm going to go to the end of this. So there might be, like, depending on exactly how your Grasshopper script works, it might not generate geometry that Revit likes, but there's nothing fundamental about how they interoperate. This is my last slide. This book right here, which I actually have a copy of right here, Dynamo and Grasshopper for Revit. This is a great book because on the left side of the page, he gives you a Grasshopper script, and on the right side, he does the exact same thing, but in Dynamo. So if you're trying to understand like how are these things the same and different, it's like 160 different, minor problems of how you do the exact same thing between Grasshopper and Revit, or Grasshopper and Dynamo.
And last question, the overall interface, because I saw that you set up your sheets and you started coding, making scripts to, if the CDs are this way, then place all these drawings, or if there's a submission that requires X, then put a perspective plan section, whatever it may be. Is there any restrictions that Revit has for you where you're going to have to maybe bypass certain Revit? I guess what I'm asking is Revit and Dynamo completely free ran to where you can do almost anything in the project? Because we're coming from an architect-based firm,
Yeah.
and I know that our scripting software,
GDL or something, right?
GDL,
Yeah.
and started to get into Dynamo, it's sort of like the Grasshopper esque version, but is there any, because ArchiCAD will not let you go into the sheet setup and do all those things. They'll let you create objects,
Yeah.
links, doors, etc. Some sort of the elements that go into it, but it won't let you kind of have full rate on your software, I guess.
Revit doesn't let you do 100% of everything, and I would say it lets you do 99% of the stuff that you want to do. So I haven't, there's maybe only like one or two minor things where I've just been like, I've come across it and like, oh, the API just doesn't let me do that. But like the Revit API is open, it's published online, you can look it up. And yeah, almost anything that you can think of that is possible to do in Revit, they let you do it with code. Some of the things in the API are not implemented in Dynamo. So in fact, there's certain like commands that you just can't run in Dynamo because no one has made that node yet. But you can actually write a C# or a VB.NET script that becomes a Dynamo node. So you can, like, that's how people write libraries for Dynamo. They write C# things and do like, compile them into like DLL files and stuff. So yeah, you can do almost anything.
Sounds like music. C#.
Yeah.
Have you had anything to eat yet?
I had a chocolate chip cookie. It was pretty good.
We have a lot of food still here, so why don't we break and anybody
Yeah.
wants to talk to you?
I'm happy to stand here and answer as many questions as possible.
One more thing.
Last question, yeah.
First of all, thanks.
You're welcome.
I think I've never seen this much interaction at an AI presentation. I think you really hit a nerve about the possibility of automation, not simplifying the workday with these computers, let's get out of things. Secondly, I guess it's more of a statement, I don't want people to miss the point, is that I feel like you don't need to jump into the whole Python.
Oh, yeah.
You can just use Dynamo to automate sheets and the number of rooms and the number of doors. I think that's a great opportunity to use the software we already own and pay for to start doing this when we get larger projects. I mean, we're not going to do a little tiny project, I mean, but it could be a time to experiment. Say, well, I'm going to number 20 rooms with Dynamo just to figure it out.
Yep.
And then you could scale it up when you have, multi-story, 300 rooms you need to renumber, or door numbers and things like that.
Yeah.
Thirdly, this is the real question, how does your term human aid what Dynamo's doing? Is there a processor? Like, because you're thinking the computer's doing it right, like what if it does it make mistakes? So that's really the third question, kind of the takeaway.
Yeah.
You're assuming it's going to make the right room numbers for a 100-story building.
Yeah.
Who's checking that? Or is that the RFI that you were trying to
So usually, there's a certain type of problem that lends itself to being scripted. And one of the things I want you to sort of come away with this is actually like problems that require nuanced judgment are really hard to do in scripting, you know? Yeah. But if you can build rules around something and you can say definitely either this is true or this is false, then you can build a script around it. So, in a certain way like that facade pattern, there's no wrong answer to that. As long as there's glass panels where there's supposed to be glass panels, there's no wrong answer to that. Otherwise, there's no one is, at least in my experience, in my office, I'm the only one that's really doing this to any large degree. And so I just try to look at as many different scenarios of how this might go wrong and try to address it before I give it out to anybody else. And even then, at times, like stuff doesn't work. But for the most part, like these problems are not ones where it's like, it's gonna cause a lawsuit, it's just gonna cause an RFI. Yeah, and like you can build in checking to certain things if you want to. So like if you wrote a script to number all your rooms, you could write another script that says, are there any numbers that are duplicated? Or I could just like export it out to an Excel file or something and just visually look through it and be like, is there anything weird here? Like if there's nothing that's jumping out at me, it's probably okay.
You just create a workflow that recognizes what's scripted, what's not.
Yes. Yeah. Yeah, and like if it were a really complicated problem, you know, you'd be working very closely with the designer, with the project architect or the engineer or whatever to be like, here's what I got out of this, but does this really, is this a legit solution? Because, you know, I don't know the problem, I'm just doing the code. Like, it does require having, you know, having more people look at it and be like, is this a legit solution? You know, and sometimes there are problems. What's that?
You're saving time, so eventually you have the time to review the results.
That's the hope. Yeah.
I think it would be fair to say, some of us don't work on it as large projects as those, but even on a smaller scale, the way we input data into our databases for schedules, details, and everything else, you'd be surprised even what Excel can do for you. And the right
Yeah.
to go in and out of that program. Like a lot of these CAD programs and BIM programs can't organize even alphabetical order certain things.
Yeah.
You could have it fall back into an Excel spreadsheet, have it organized, and throw back into the system again. So I guess, I mean,
Yep.
those are things I can see at a very simplistic terms that can save us a lot.
Yeah. And to go back to sort of an earlier question about do you need to go into Python? You don't. What I actually found though is that after I learned Python and had to be a little bit more rigorous in like understanding what is these data types and functions and all this stuff, it made me understand how Dynamo worked a lot better. I was a lot more comfortable putting together a really long Excel function, you know, and understanding like looking up on the Excel documentation online, like what do all these functions do and what does this stuff mean? But yeah, like we can use these ideas in lots of different things. You can do them in Excel and lots of other things. So yeah, I encourage you just to try to think about your problems in that sort of way. Like, is it data? Is there a way we can quantify this, or put like a box around something to say, you know, we're this category we're doing one thing, this category we're doing another thing. If you can do that, you can probably automate some portion of it. So, all right, I'm happy to answer as many questions as you want, but yeah, you guys should have more food and drinks. So thanks a bunch.
Thank you.
And have a good night.